Hey guys, these notes are for the new exponent laws. So we're reviewing all of the exponent laws that we have already learned in Unit 1, which is quite a bit ago since this is Unit 6. And then we're going to learn 2 more laws that we are going to use, and then we're going to combine them all together. So our essential question is, what are the laws of exponents and when should they be applied? Okay, I apologize for my voice. I have bad allergies, so I don't sound very good right now. So this first section is all review. This is stuff that we learned Unit 1, and we did review it for the midterm, so this is not new material here. So the product rule is the first rule that we learned. And here, let's review what these are called. So these are called exponents, and hopefully you remember that. Those are our exponents, and then these down here are our bases, okay? So they have the same base, and their exponents are different. And so when I have something with the same base and they're being multiplied, I'm going to add the exponents, okay? So, when multiplying numbers with the same base, you add the exponents, okay? So, like a review from Unit 1, let's do an example really quick. 2 squared times 2 cubed, okay? Well, 2 squared is 2 times 2, right? Because it's 2 times. And then that's times 2 cubed, which is 2 times 2 times 2. Well, that's 5 2's all being multiplied together, which gives me 2 to the 5th. So you do add the exponents here. Okay? Now let's do number 1 together. So you always want to, it's kind of like combining like terms. You want to multiply your like terms. So I know that my 5 and my 2 can multiply. That gives me a 10. And then x squared times x to the 4th is 6 x's that are being multiplied together. So I have x to the 6th. Okay? Number 2. I have two like little expressions here being multiplied together. My negative 4 and my 2 can be multiplied, so that's going to give me a negative 8. And then I have my x to the 3rd times x to the 4th over here, so that's going to be x to the 7th because I'm going to add the exponents. And then next I can use my y squared and my y. Now that y, there's only one of them, and we usually don't write the exponent, but it's technically to the first power. So I have y to the 2nd times y to the 1st, which is going to be 3y's. Again, none of this is new. If you're needing some additional help with these rules, please come see me before or after school so I can help you with that. But I'm not going to spend that much time on it because it is, or at least in this video, because it is review. Alright, and so this is the power rule, and this is when we have a base to an exponent, and then on the outside we have another exponent. So normally when we have, like, let's say 2x plus 4, what do you want to do to get rid of those parentheses? You want to distribute. So you're kind of doing the same thing here with the exponents. To get rid of the parentheses, you want to distribute that in there. So you're going to take a times b. Okay, so that's your power rule. So you can think of this as distributing the outside exponents to the inside exponents. Okay? You want to think of it like that. If you are not taking notes right now, you are wrong. You need to be taking notes, so don't give me the excuse me like, oh, I'm watching on my iPad. So you can go ahead and print the notes out and then take notes while you're watching the video. Alright, number 1. So we have a parentheses here, and we want to get rid of that, so we're going to distribute that too. Now inside my parentheses I have 2 things. I have an x and a y. So you need to make sure that when you distribute that 2, that you distribute it to everything inside. So since I have 2 things, I distribute it to both. So the exponent on my x is technically a 1, so 1 times 2 is 2, so I have x squared. And then I have y cubed to the 2nd power, which is going to multiply and give me y to the 6th. Okay? Next one, I have 3x to the 4th squared. So again, I'm going to distribute. Now, this is going to go on top of that. My 3 technically has an exponent of 1 because I have 1, 3. So that's going to be 3 squared. And then x to the 4th to the 2nd power is going to be x to the 8th power. And then 3 squared is actually 9. Okay, it's not 6 because, remember, squared means multiplying it by itself. So 3 times 3 is 9. And then we have x to the 8th. And that's our final answer. You want to simplify as much as possible. So since 3 squared can be simplified more to 9, then you simplify it. Don't just leave it the way it is. Another rule that we learned in Unit 1 was the quotient rule. Now this is when I have the same base but different exponents. And that when you're going to do there is you're going to want to subtract. So you're going to a minus b. Okay, now let's review something from the unit 1 so to refresh ourselves here. So I have x to the 5th over x cubed. Okay, let's expand that out. So x to the 5th is x times itself 5 times. And then x cubed is x times itself 3 times. Okay? Now, when you have like 22 times 4 divided by 2, you can cancel the 2. So here I can cancel some x's. I can cancel that one, and that one. So how many do I have left? I have x times x in the top, so I have x squared over 1. So it's just x squared. Okay? That's just doing 5 minus 3, you get 2. So you don't want to have to expand it every time. It's really helpful to know these rules. So when dividing numbers with the same base, you subtract the exponents. Okay? So basically you're doing top minus bottom, and then your answer is typically in the top, in the numerator. Alright, number 1. So I have x to the 4th divided by x. Now remember, you can only combine the ones that have the same base. So here I have 4, and I technically have a 1 here. And when I subtract that, I'm going to get x to the 3rd. Okay? And then I have y cubed divided by y squared, which is going to be y to the 1st power. Okay? Because it's 3 minus 2. Now these are technically over 1, but you don't have to write that. It's just like when we write 3, we don't write 3 over 1 every time. Okay? Now here, I'm going to simplify my x's first. I know that I have a 9 and a 3 here. So I'm going to go ahead and copy down the 10 and 4, and mess with that later. Well, I have 9 x's on the top, 3 x's in the bottom. If I were to cancel stuff out, I have 6 left, and they're all in the numerator. They're up here. Now we're not quite done yet because your fraction can be simplified. 10 divided by 4 can be simplified to 5 over 2. And then the x to the 6 is still up there. Okay? You know you've simplified when there's only one of each variable, and the fractions and numbers are all simplified. So like here, I had 2 x's and 2 y's, and now I only have one of each. So you only want one